Hello viewers, in today's class we are going to discuss one important definite integral, right? And here we have this problem, that is we have to find the integral of this function, that is sine 2x tan inverse sine x dx from 0 to pi by 2, right? So let us call this integral as I, and here when we solve this integral, we'll make use of the method of substitution, right? And moreover, while using the method of substitution, we'll change the limits, and then we'll reduce this integral in which the integrand is a product of two functions, right? And to calculate the integral of the product of two functions, we'll make use of the method of integration by parts, right? So basically this integral would be solved first by making the use of method of substitution, and then we'll make use of integration by parts, right? So let us start. So here first of all, see, here we have sine 2x, right? So we'll use the important identity from trigonometry, that is sine 2 theta is equal to 2 sine theta cos theta, right? So we'll replace sine 2x by 2 sine x cos x, right? So we have 2 sine x cos x and tan inverse of sine x and dx, right? Okay, now here we see that here we have the term sin x, and here also we have the term sin x, right? So if we substitute t is equal to sin x, then the derivative of sin x is cosine x, right? And we see that the derivative is present in the integrand, so we can take this substitution, t is equal to sin x. So if we differentiate, dt over dx is cos x, and dt is equal to cos x dx, right? So for cos x dx we can take dt, right? So here we have cos x and here we have dx, and here we can take t, here also we can take t, right? And see, the limits varies from 0 to pi by 2. So when x is equal to 0, we can calculate the value of t from this substitution, that is t is equal to sine of 0. Sine of 0 is obviously 0, and when x is pi by 2, t is equal to sine pi by 2, right? And sine pi by 2, that is sine 90 degrees, is equal to 1, right? So when x varies from 0 to pi by 2, t varies from 0 to 1, right? So now we can write our integral I as 0 to 1, and we have here the factor 2, then sine x is replaced by t, and for cos x dx we can write dt, and tan inverse sine x is replaced by tan inverse t, right? And here we have dt. So now we can take this to outside the integral, being a constant here. So we have 0 to 1, and we have t times tan inverse of t dt, right? Okay, so now here we have the product of two functions, right? So t is an algebraic function, or we can say t is a polynomial function, right? And tan inverse t is an inverse trigonometric function, right? So now we have the product of algebraic function and inverse trigonometric function. So what we will do, will make use of the method of integration by parts, right? So first of all, what we will do, we'll find out the indefinite integral of t times tan inverse of t, right? And we'll call this integral as I1, right? And once we get the value of I1, we can substitute the limits and we'll take the difference, and we can easily get the value of I, right? So let us first find out I1 by method of integration by parts. So now let us first quickly see the definition of integration by parts, or the rule for integration by parts, right? Suppose we have the product of two functions u and v, right? And u and v are functions of x. So this we can take u as the first function and v as the second function. Then the rule of integration by parts says that first we take u, then we multiply it by the integral of v, that is u times integral of v dx, and then here we have the integral, and then we differentiate u with respect to x, and then we find the integral of v with respect to x, and then we finally integrate this term with respect to x, right? So this is the rule for integration by parts. So here what we will do, we'll take tan inverse t as u, right? So we'll take u as tan inverse t and v as t, right? So v is t. So the algebraic function is taken as the second function, and the inverse trigonometric function is taken as the first function, right? So now if we take or if we substitute the values of u and v in this formula, see, then we will get tan inverse t, and then we have the integral of t with respect to t minus then we have the integral, and then we have the derivative of tan inverse t, because u is tan inverse of t, and then we have integral of t dt, and here we have dt, right? Okay, now here the integral of t is t square over 2, so we can now write tan inverse t. Here we have t square over 2 minus integral, the derivative of tan inverse t is 1 over 1 plus t square, and integral of t is t square over 2, right? And then this whole term would be integrated with respect to t, right? So now let us simplify it. So we have t square over 2. We can take this term in front of tan inverse t. So here we have tan inverse t minus, we can take half outside, then we have t square over 1 plus t square dt, right? So now we have to integrate this term and see what we will do. This is a simple integral, and see here in the numerator we have t square, and in the denominator we have 1 plus t square, right? So what we will do, we'll write this term t square as 1 plus t square minus 1, right? Because this one and this one get cancelled, and we are again left with t square, right? So here we have t square and dt. Okay, so now what we will do, we'll break this integral from this point. So what we will get, we'll have t square over 2 tan inverse t minus half, and we have integral, and when we break this integral as a sum of two integrals at this point, then we'll have 1 plus t square over 1 plus t square minus 1 over 1 plus t square and dt, right? Okay, so now let us simplify this expression. So we have I1 is equal to t square over 2 tan inverse t minus half, and here we have the integral, then 1 plus t square and 1 plus t square get cancelled, we are left with 1 minus 1 over 1 plus t square and dt, right? So now let us write t square over 2 tan inverse t minus half, and see the integral of 1 dt is simply t, and the integral of 1 over 1 plus t square is simply tan inverse t, right? Because the integral of 1 over 1 plus x square is equal to tan inverse x, right? So here we are not writing the constant of integration, because finally we have to substitute the limits. So here we'll omit the constant of integration, right? So we have t square over 2 tan inverse t, and then we'll multiply these two terms with minus half. So we have minus half t plus half tan inverse t, right? So the indefinite integral of this function, that is t times tan inverse t, is given by this expression, right? So now we have to find the definite integral of this function. So what we will do now, I is equal to 2 times of I1, and the limits are from 0 to 1, right? So now we have 2 times, here I1 is t square over 2 tan inverse t minus half t plus a half tan inverse t, right? And the limits are from 0 to 1. So now let us simply substitute the limits here. So we have 2 times, and see, when we take 1 here, we have 1 square over 2 tan inverse 1 minus half of 1 plus half of tan inverse 1, right? And when we take 0 in this expression for t, see, all the terms are equal to 0, because this term is 0. When t is 0, this term becomes 0, and when t is 0 here, tan inverse of 0 is 0, right? So here all the terms are 0, so we'll have 0, right? So now I is equal to 2 times, and here we have half, and tan inverse of 1 is pi by 4, minus, here we have half, and then we have plus half and pi by 4, right? So tan inverse of 1 is equal to pi by 4, right? Okay, so now if we multiply these terms by 2, this 2 and this 2 and this 2 get cancelled, so we are left with pi by 4 minus 1 plus pi by 4. So this is 2 pi by 4 minus 1, and that is pi by 2 minus 1, right? So this is 2 to the 4. So the value of this integral is equal to pi by 2 minus 1, right? So viewers, this is how by making use of the method of substitution and integration by parts, we can solve these type of integrals.